Yeah, good afternoon. No, yesterday the 1 week long program on the geospatial modeling driven urban hazards and risk analysis that began. And the first day you heard about the overview of the urban hazards, different kind of hazards. Now we are unfolding that subject. On the first day you are going to deliberate on particularly on the urban floods. So in the recent times, no, the intensity of the urban floods is rising as it was not heard previously, and as the process of urbanization is building up, this is also scaling up the urbanization processes. Urban flooding processes. So when we say urban flooding, it is nothing but the inundation of land and property in a built environment, particularly in a densely built up areas, and which is caused by rainfall. And this rainfall exceeds the capacity of the drainage system such that the streets are overflown and it chokes the drainage system and life comes to a standstill. So because of this, issue is picking up, and during the time of urban floods there are loss of property and maybe the loss of life as well, and also subsequently after the flood recedes there will be health concerns as well. Now these urban floods are triggered due to several reasons based on meteorological characteristics, or based on the topographical characteristics, or based on the location of the city. So it may be, first of all, it will be because of the excess rainfall, and which is caused by because the ground is no more able to soak the water. So the ground saturation has got at minimum level, and that's how the streets gets flooded. The second reason may be because of the overflowing of rivers, because the cities, they are co-located along the water bodies, and in such rivers what happens that because of the large amount of water which is coming from the upstream, that will overflow and try to inundate the urban settlements within its vicinity. The third thing is because of the extreme coastal events, cities which are in the coastal region, because of the various kind of meteorological anomalies, such cities receive excess quantity of rainfall because of certain cyclonic or other events, and this causes the inundation on the streets. And the fourth category will be because of the catastrophic failure in the infrastructure like the dams, etc., which are built coexist near to the city. Once this happens, like you're seeing now in the recent times following the earthquake, now there is also break in the dam near to the Turkey. Some cities in the Turkey, and where the following the earthquake, now there is flood is also happening. So as I said, that intensity of the floods in the recent times in Indian cities are rising. Now it is year after year we are hearing that particular cities or several cities across the country or in other parts of the world, they are under the floods. Now those cities, typically any city will have variety of land uses and variety of their density and other things will be there, but what is happening that because of the excess capacity of the rainfall which has occurred, that has choked the drainage system, and not only the slums and squatters but the areas which are so called the planned areas as well, they're also getting inundated. Like for example, the previous year we heard about the Bangalore city. Now the Bangalore as such, there is a large area is planned, but the density of urbanization is increased. You know that it was called as the city of lake, but in the recent times and over the processes of urbanization, we have lost several water bodies, and which has caused inundation. So people are trying to look back and trying to find out what has gone wrong. Accordingly, those where those lakes, they have disappeared, or the linking all those lakes with their linkages, interlinkages also got disturbed. If you go further years back, you heard about the floods in the Chennai, you heard about the floods in the Hyderabad, or in the previous year heard about the floods in the Vadodara because of the overflowing Vishwamit river. The creatures know that creatures within the city, I mean in the river, they lost their path and got into the city lanes and by lanes. Or you see that Bhubaneswar was the first city which was announced under the list of smart cities, but there also some parts of the city also get inundated. Before that, if you go look back, know that in the Srinagar city also, because of the large amount of rainfall it received, and also because of its all edaphic and bio geographic characteristic, the city was inundated for several days. And there are cities which always, like cities like the Mumbai or other cities also, now and then, as soon as the rainfall monsoon starts and the inundation begins. So that's how such kind of urban floods, their intensity, their propensity, their loss of life or loss of the infrastructure and other day-to-day life of the urban dwellers, that is getting affected. So there are several kind of economic process linked economic studies have been conducted, whether in India or it is conducted at global level. And among all kind of hazards which are inflicting our cities, it says flood is, in the case of in the global phenomenon, the flood is one among such hazard which is causing the massive damage. And it is just next to the earthquake in terms of the economic loss to the society. Okay, if you look at our country, you know that among all kind of disasters, the flood is the one which is causing the maximum loss, and that is of the tune of close to $7,400 $1 million, which is reportedly being lost because of the floods which affects whether it's the urban or rural areas. That's how we have to be concerned. We have to find out the ways and means that how to deal with such rising instances of the urban floods. For the reason being that when we in the previous century, in the first decade, our urban population was less than 10%. Now you see that now, as per the recent census 2011, and the next census is due, but already as per the 2011 census our population has exceeded 31.16%, and there are estimations that by 2020 already we have crossed 35%, and the times in the to come in the 2030 our urban population will be going to rise close to 40%. So in a small part of the land surface, large urban populace that resides, they are becoming vulnerable to the various kind of hazards, and among such hazard the flood is more pronounced. Now you see what happens as the densification happens, particularly have not section of the society, they are they have not any means, they have to reside particularly in the slums and squatters or in the hinterland. Such land are often they're prone to the disaster is so high that it becomes the news year after year, and that's how it causes the loss of life and property. It causes the disruptions of the transport and power. It also causes, following the aftermath of the such kind of hazards or disaster, it causes the epidemics, and then there is, as such, there is a loss of life there is a loss of infrastructure, and there is loss of economic to the country as a whole. So in such cases we have to come out with the solutions, all kind of viable solutions to ease the such ease the life of the urban dwellers. Now there are studies which have been carried out which says that typically such urban floods are of three types. First is type A, which is localized flooding. Okay, so localized flooding which is caused by the inadequate drainage capacity. Water gets stagnated over only shorter duration of the time, and it will happen, I mean, in any part of the city depending on the urban density and the capacity of the drainage system, but the water will not remain stagnant for a longer time, but certainly it for there will be brief lull in terms of urban movement mobility, and also following the occurrence of such type kind of flood, I mean, there will be kind of health issues and other thing. But at the same time, we also know that it also naturally scavenges the urban surface. But at the same time, we know that other though there are some negative impacts are much larger than any kind of positive benefit that we derive from such kind of incidences. Type B occurs which is more pronounced than the type A and affects the larger areas. It disrupts the transportation system and also conveys the large scale inconvenience to the city life. And what happens that following the occurrence of such, when the water recedes, then the water related diseases also comes up and affects our day-to-day life. It also cause various kind of when the water remains stagnated on the streets, it might affect the structural characteristics of the infrastructure. So one has to be cautious like, and that's how the type B stands. In the type C, which is more pronounced, and it is the matter of great concern when the inundation remains for several days. Okay, and this causes disruption and affects the business or community as large for several part of the days, I mean, now part of the month, particularly when the flood occurs. So as such, these are the three types of the urban floods, and the causes, as you know, the causes are natural, human, and hydrological. Under the natural causes, it is because of the various kind of natural phenomenon like various kind of meteorological disorders, or it is because of the proximity of an urban settlement close to a river. Because now the second thing is the human causes. Under the human causes, the urbanization processes, the density of urbanization, or also extension, rise of urbanization or the spread of urbanization. That means the urban growth, urban built up, okay, or encroachment into water bodies, or silting and clogging of drainages, urban drainage system, and also the decrease in pervious characteristics of the land surface, or the rise in imperviousness. So these are the human causes. Subsequently, this also changes the hydrological behavior of the land mass. Okay, so that's how when it happens, what will happen that because of the rising imperviousness, lesser water will seep into, more runoff will be there, and what will happen, it will change the soil moisture level. So these are the three major reasons which attributes towards the urban floods. Now let us try to understand that in terms of the hydrologic properties, what happens, why the flood is caused. See, you are seeing two hydrographs. I hope you are aware about the hydrograph. Hydrograph is the plot of time versus the discharge. Now see, when the natural surface is there, so you are seeing the bottom hydrograph. This is the hydrograph which belongs to the natural watershed. Okay, so what will happen that the time to peak is delayed, and also the magnitude of the peak runoff is also delayed. So as such, we have got more base flow, there is more time for water to seep into the land surface, and the peak volume also will not so high. But as the urbanization happens, what will happen? It alters the hydrology of the region. It changes the shape of the hydrograph. The time to peak will occur shortly as compared to the natural watershed, and there will be more peak runoff. So, more water will be coming on the street in a lesser time. So, city is not able to cope up with the volume of water which is coming in a relatively shorter time, and that's how the flood will occur on the street. Let us try to understand from the remote sensing perspective that why the cities are more and more inflicted with the urban floods. See, some of our metro cities, no, sorry, some of metro cities, what we are doing in the our ancient cities, they are self-sufficient in terms of the coping with the urban floods. That there were plenty of water bodies that tradition, I mean, all over the country we have got the traditional water harvesting structures like the nadi, khadin, pond or detention dams, etc., etc. So many are there across the country. So what they used to do, they used to absorb the water during the peak time, and the such water was used during the lean time. That's how that there were cities were so self-sufficient that in the absence of municipal water supply, even the locals were able to draw the water from such kind of water bodies. Now, in the process of urbanization, what we did, that our greed and also our need, that what it caused, that we have leveled the such kind of wetlands or the water bodies, as you see 2003 to 2018, a part of the land surface where the water bodies got delinked, okay, and in between the leveled surface newer urban settlement had come. So you will agree with me that in the process of nation, now there are two processes here. First of all, there's such a large water body which has got its own catchment, and is also connected with the adjoining another water body. Okay, it was also connected with the adjoining other water body. So anytime the excess water is coming, first of all it will try to absorb it, and then excess water it will further outflow and go into the another water body which is downstream. So that's how such kind of water bodies, first of all they were larger capacity, and also they were interlinked. So but what we did, that first of all we reduced its capacity, and also we got it delinked. So what will happen, its after effects will be that such areas water will overflow, and not only it will overflow, it choke the entire urban drainage system. Cities will be, or the streets will be waterlogged, and also that it has got other effects as well. So like you see that such kind of where we are playing with the land surface, land mass, and it will surely going to have such kind of effects. Now you see in the terms of time series satellite data, what is happening to such kind of cities, our metro cities, that in the process of urbanization, first of all we are grabbing the land, okay, we are grabbing the land and we are making them in isolated manner, and also we are delinking them, their capacity is getting reduced. So flood is surely going to come, okay, we are only responsible for that act. So this is the first, as I said, that this is the physical characteristic, this is the physical attribute. Okay, now once this all happens, remote sensing is the solution which can help you helps you provide with authentic figures how the such land use transformation is happening. So on one side you seeing here that over the period within a planning area boundary, how the built up is rising. Okay, there are studies which have been conducted by several institutions in the country, and they have reported how we have lost the water bodies over the period of time. But these are the studies where the source, no, first of all, it may be unknown, it may be guesstimate, or it might be done based on the classical methods. But the remote sensing data provides the time series information, where you can use various kind of classification algorithms. It may be pixel based, it may be neighborhood based, it may be elementary supervised classification, or the index based classification, or you can use the machine learning based algorithms to decipher the water body and other surfaces. For the reason being, because the water body is unique, that its signature beyond the blue region, it diminishes. I mean, it becomes close to zero, while other features, it will manifestation will be much brighter, and depending on the characteristics of the water body, and that means in terms of the suspended sediment, in terms of depth, so the accordingly its digital number or its reflectance will change. But this how we are able to segregate the water and non-water. So once this is happening, then we have got the time series remote sensing data. So what we try to do, you might have heard about the corona satellite data, which was declassified, okay, by the Western world, right? And the same data we got it downloaded, and then we got it thresholding based classification we applied. Subsequently, we used the other Landsat based satellite. Though I mean, there is a caution here that while doing such kind of change detection analysis, one has to be, I mean, use the uniform satellite data. But we do not have got any other source to identify the land surface prior to the launch of the 1972. Okay, since the launch of Landsat satellite, and later on we have got in the recent times several satellite data are present. So what we try to do, we try to do such kind of classification. Once we did, we are able to find out that as you see on the right hand side, built up is increasing. On one side, the we are losing the water bodies. When you try to do, we found that there's a decline of close to 65% of the water bodies during the period 1965 to 2018. So that is kind of phenomenon is happening not only in Bangalore, several other cities in our country and in the world it is happening. So that we can quantify. I'll also like to mention that in the recent times, we are having the plethora of data. So such kind of data sets, then we have got also the advancements of the machine learning based algorithms, various kind of advanced classifiers have come. We also heard about the Google Earth Engine, which is the based on spatial data cube principle that helps you, not only it provides you the data, also it helps you to apply the various kind of analytical tools on a single platform. So one need not download the data, one need not fetch the class, apply the classification algorithms. Everything is available on a single platform. That's how you are able to fetch the time series based information. So once we did it, so for several tools we developed our toolbox, and then we tried to assess how the built up is changing in different parts of the country, in different cities in the country. We've seen that how that like in the Hyderabad or Pune or several other cities in the country, we have developed such kind of toolbox to analyze over the Google Earth Engine platform that how such kind of phenomenon is happening. There are literature which says that if there is a 1% rise in the impervious surface, and then it will further accentuate the flood incidence by 3.3%. So you see that more and more cities are getting densification happening, more and more urbanization is happening, more and more impervious surfaces are rising. It will further accentuate the flood instances. So we have to be understand the total process, not only the built up. That means on one side, land surface phenomenon are changing. Okay, in the sense like the built up is increasing, water bodies are dwindling, also vegetated surfaces are dwindling. Not only this are happening, on the other side also the rainfall variability is also rising, like extreme events are rising. You know that in our country there are agencies which regularly monitor the water in the rivers in several parts of the country. So what has been reported, that based on the given threshold during 2019 monsoon period, the number of extreme events which occurred during the monsoon month, that has increased. So you see that as you see here, that number of extreme rainfall events over the period, that is also rising. So on one side, as I said, land surface is changing, and on the other side, that extreme rainfall events are also increasing, as observed based on the water level estimation in various major rivers in the country. So that's how we have to flood instances are rising. Now what can we do? Now you will agree that estimation, no, to find out the instances, to assess the urban flood characteristics of a city, we have to do some kind of mathematical computation. There are several methods are available which helps us to understand the urban flood characteristics. Now you see, this urban floods is a subject which can be dealt by assessing the runoff. When you have to assess the runoff, this runoff will not be the average runoff. This average runoff will be either the event based or on a long term continuous basis. We have to assess the peak runoff. Okay, so why the peak? Because the flood is correlated with the peak instances. So there are methods which have been developed over the period which helps us to assess the peak runoff. One such method, which I hope you may be aware, is called as rational method. So rational method is a method particularly applicable for the urban areas, which helps us to compute the peak rate of runoff, and particularly from all different kind of impervious surfaces of variety of characteristics. Okay, though rational method is very well used, and initially it was developed for the areas less than 20 acres, but it has found wide usage. So people are very popular. It is a very popular method which is widely used by the researchers across the globe. But there are other methods also which is given by the Soil Conservation Service of the USDA, okay, United States Department of Agriculture, that is called as SCS 55 method. Okay, so again this method is based on the SCS method, initially runoff curve number method, and one has to find out what is the runoff characteristics on a given area based on the curve number method. And then this method is applicable for relatively larger area, and also this method is used for the erosion and sediment control activity. There are other methods as well, like the SCS TR20 method. Okay, this method again, it is devised by the Soil Conservation Service, and it is based on again certain characteristics or attributes of the catchment for variety of situations within the given catchment. This method is very popular, it can be used. Another method is called as SCS TR55 method, and which is found wide uses even because this is far more applicable for the watersheds where the area is close to 2000 acres. Okay, and such method, no, they have been further customized, and the tool has been developed, online open source tool like HEC, which is developed by corps of engineers, okay, in the United States, and which is available for freely downloadable, and such method can be used. So these are the methods which are available for assessing the peak runoff from an area. But when, as I said, particularly for urban areas, the most popular method is rational method. Okay, now the rational method, where the peak runoff or the peak discharge is computed as Q is equal to CIA. Now the C is the runoff coefficient, I is the design precipitation intensity, and A is the area of the watershed. Okay, so one has to find out the three variables CIA. Now the A, you know that area of the watershed can be computed based on various traditional or the modern approaches. Now the traditional method, you know that one has to go to the field, and then using the traditional surveying methods one can find out the area of a catchment, but that is very time consuming. That's how we have got the topographical maps. Okay, and using the topographical maps, while following the drainage system, while following the contour, one can find out the how much the area of any watershed is there. But you may agree with me that in the urban areas, typically the topographical maps are available for maybe as 1 is to 50,000 or 1 is to 25,000, where the contour interval is either the 20-40 meter, or for 50,000, or at a scale of 10 to 20 meter for the 1 is to 25,000. Okay, such contours are inadequate to delineate the micro watershed within a city. So that's how in the modern times the remote sensing derived digital elevation models are quite handy. Using such a model, people are able to delineate the watershed, and down in the line we are able to delineate the micro watershed, etc., within an urban area. Okay, then further, if you have got the LiDAR based survey, that will be far more useful for delineating the LiDAR based DM will be useful for delineating the micro watershed within the city. So to this, how we are able to assess the area of the micro watershed or the micro catchment in a within an urban area. I is the design precipitation intensity, which is defined based on intensity duration curve, which is nothing but a plot of nothing but a plot of the duration and how the frequency of rainfall is changing within a given area based on different frequency, or based on different return period. So based on the presumed return period, we have got the standard nomograph that can be utilized for assessing the I, that is the intensity duration frequency curve, where I can also be further defined based on the numerical formulation, where area specific coefficients are available for understanding the I characteristic, that is the design precipitation intensity. Now to understand the C, that is the runoff coefficient, one can do the land use classification and also attach the slope attributes. Then we have got the standard table is available. Using that table, we can assess the runoff coefficient within an urban area. So that's how, using the rational formula, we are able to assess the peak runoff in any given urban area. Okay, now the question comes, you have found out the peak runoff from any given urban area for a given micro watershed. Now we have to also think about that in any given urban area there are urban drainage system is also available. So how much this urban drainage system is stormwater drainage system is able to accommodate, how much it is able to evacuate. So that means certain amount of peak rain runoff is coming as you have computed using this formula. Okay, now what we have to do, that that particular volume of runoff per unit time, now we have to assess that this particular volume of runoff which has come, then what is the capacity of the urban drainage system, how much it is able to evacuate. So when you do such kind of comparison, then you are nothing but what we are doing it, we are doing entering into the domain of water balance. This water balance states that the depth of runoff on any given street, that is a function of how much the rainfall has occurred, and then how much is the evaporation, how much is the infiltration, how much is the runoff, and how much water is getting stored within that depression, within that micro watershed or any other hydrologic entity. So if you do, then based on the hydraulic properties of the urban drainage system while applying the Manning's equation, then you are able to find out that within that urban drainage system, how much the residual water which is still present on the street, which the present urban drainage system is not able to evacuate, right? So that's how we have got the kind of no analysis where we are trying to, on one hand we are trying to assess the volume of water which is coming as an after effect of the rainfall which has occurred, whether the streets are capable to hold, evacuate, drainage system is available to evacuate this much water, or they still remain present because of the inadequate capacity of the urban system. Now incidentally, let me mention here that we have got today the software, whether it is open source software or the commercial software, where what one can do, one can map the built up, different kind of land uses within a city. Okay, so those land uses are helpful for assessing the how much the friction for a given land use will occur. Okay, how much water it will able to absorb, how much the water it will try to release, and that means the hydrological characteristics of the land surface we are able to diagnose based on the land use characteristics. Then given the urban drainage system, we try to assess that how much the depth of water will remain on the street per unit time based on the conduits, junctions, and other characteristics of the urban stormwater drainage system what we have given. One such software is called stormwater management model, okay, which is the open source software, which is the GIS coupled software, hydrological software and hydrodynamic software, which helps us to assess the residual water, which will be remain on the street, how many part of the city will remain stagnated because of varying intensity of rainfall. Okay, here it is very important to mention that we are dealing with the floods. Now the flood occurs because of the intensity of rainfall which is translating into the runoff, and the such instances are happening because of the varying intensity of rainfall. Okay, so in the river or in the drainage system, you see on the right hand side picture, schematic diagram, what you're seeing here, that if a 2-year flood will come, the river will be at its lowest level. That means FRL of the river will be very, very low. But this will be happening almost every year. But we need not worry, because the capacity of drainage system is river is so high that it will not affect the urban drainage, cities in the vicinity. But suppose any rainfall occurs and which is translating into the runoff, which is happening once in 100 years. So what will happen? The river will be overflowing, the excess water will be coming on the street. And you see now that if you remember that Vadodara city, what I cited, that where the all kind of aquatic creatures, they were lost their path and got into the city. That's how we have to concerned about the high return period based floods like the 100-year flood, which will be happening once in 100 years, and though the probability is low, but whenever it will occur, it will surely going to affect our day to day life. Now, keeping this in mind, let us take you to the some of the case studies which have been published or we are still working on. Okay, so because this is the issue coming up issue in terms of the hazards which are inflicting our cities. One such as I said in the prelude of this my deliberation, the two major hazards which where we are concerned is most, like the first is the seismic, second is the urban floods. Okay, like as I said in the beginning of my deliberation that we had in the Turkey, in the country Turkey, we have got a very high intensity and high magnitude earthquake which has occurred, but that is also caused the damage to the dam which was there in the vicinity. So those water which was retained within the dam, now that is has come within the city. Now cities are waterlogged. Think about no that on one side the relief and relief team, no, they are working the day and night to search the life which is buried within the debris, and other side the streets are waterlogged, no. So how difficult the life would be there, one can understand, right? No, so that's how I'll just take you to the city. Bhubaneswar is the city which was top in the smart city list. 2016 when the government brought out the list of smart cities, Bhubaneswar in the top. But if you remember, the one of the first photograph where I showed, that some part of the city which appears to be the not the slum and quarters, where the city is waterlogged. So what I try to do, we try to assess it's the urban flood hazard, which part of the city which is most affected, what is the intensity of hazard, what will happen, kind of no scenario generation. So that we try to do. While we are doing it, we are looking for the high resolution DEM, and then we got it. So what we try to do, we try to assess the urban stormwater drainage system, and also we try to delineate the urban water stormwater drainage system using the LiDAR based DEM which was available there, and we found to be quite useful. After running the stormwater drainage system, then we try to assess the volume, and based on the given intensity of rainfall for 5-year return period, 10-year return period, and the 20-year return period, where the intensity of rainfall was computed as 2.203 millimeter per day, and to the 20 years rainfall as 297 millimeter per day. The depth of runoff which was there on the city for 5 years, it was some part of the city was ranging from 0.6 to 0.7 meter. For 10 years it was 0.7 to 0.9 meter. For 20 years it was above 0.9 meters. See, think about when the close to 1 meter water for certain period of time when it is there, I think at least the lower part of the building and the streets will remain such waterlogged. It will be difficult for the urban dwellers or the urban commuters to come out on the street and then meet their day-to-day need. Okay, so that's how we try to assess what will happen, especially for 5 years, how much part of the city will be inundated. For 10 years, how much the part of the city will be inundated. For the 20 years, how much part of the city will be inundated. Already you know that the risk is a function of hazard and vulnerability. Hazard we assessed using the stormwater management model, and the vulnerability of the urban dwellers we try to assess based on the various demographic and social characteristics in terms of the physical attributes, social attributes, and in terms of the coping capacity. Then we try to assess that in terms of the which are the wards which are more vulnerable to the based on the characteristics of the urban dwellers based on the characteristics of physical attributes which are most vulnerable, which are lesser vulnerable. Okay, then we try to take out the product of the hazard and vulnerability, and then we are able to find out for the 5-year return period, for the 10-year return period, for the 20-year return period, which part of the city will be more prone to the urban flood risk, and which will be lesser. Okay, so such kind of analysis we try to do. Now coming to the second point here, that we also have to understand what are the remedial measures. You see, as I showed in the initial slide, know that we are losing our water bodies. We are also losing our green surfaces. So green surfaces, that means the urban green spaces, that is when we are losing it, so we are reducing the infiltration characteristics of the urban system. Now this kind of urban green spaces, they are categorized into several types, like the green roofs, blue roofs, rain garden, permeable permanent, and others. Okay, like the green parking lots, etc., etc. Okay, so each no, not only you can create the green spaces on not only in the vacant areas, one can also have the row or avenue trees. One can also create the green spaces on the roof. One can also create the green spaces within one's bungalow. So this way along the rivers. Okay, so different part of the city on different land use system, one can create the green spaces, because each such kind of green spaces will surely absorb some quantity of rainfall or the runoff, residual runoff, and it will de-accelerate the process of runoff generation, and subsequently it will retard the urban flooding process. Okay, so what we try to do, quickly let you know that we try to assess the present urban green spaces, and then we try to see the past, present, and also the future built up. See, you know that urban growth modeling lets us work out that what was the built up in the 10 years and 20 years. Okay, then what is the situation now, then what is the situation going to be in the future, that we can work out based on urban growth modeling principles. Okay, if such kind of built up is happening, it will certainly change the other land uses. Then we try to find out that which are the areas which are suitable for creating the urban green spaces. If that is so, then we try to assess that what is the, suppose based on the Q is equal to Ci, that is the runoff method, that what is the baseline scenario, what is the worst scenario, what is the green scenario. That means we try to assess that what is the impact of green spaces on retarding the peak runoff, or if in the absence of the green spaces, what will happen, that more urbanization spaces will increase and it will further accelerate the runoff. Okay, so that kind of analysis we try to do. See that you already know that in the process of hazards analysis, we have got stages. Best is that early warning system. You create some kind of early warning system, but otherwise we have to come out following the occurrence of the disaster in some part of the city. Then we have to come out with the remedial measures, and those remedial measures will be response, relief, and restoration. So what we try to do that because whenever the flood occurs, normally the flood occurs during the monsoon period, and during those time the area will be cloud content will be so high. Using the optical data, we will not be able to see the surface beneath. That's how the microwave data will be handy. But sometimes, no, when the cloud presence is not there, optical data will not, I mean, will be useful. So we try to see, like here in the Srinagar city, that you see that the streets, no, they are choked with the stagnated water. So which are the part of the city where the water is still present, that is possible. Okay, where the applications of microwave also come. Now let me take you some of the ground reality. What we are doing with our city, we are treating our drainage system or the rivers within our city like the dumping yard. So what we do, any kind of filth or the waste material, we try to dump within the our city. Okay, like you see here, as if they are the dump yard, we are treating them like this. Or the, because these kind of urban drainage system, they have got a inlet. So often what happens during the scavenging process, because of natural or because of the man-made action, the inlet to the urban drainage system gets choked. So what will happen? Streets will get waterlogged. Now, in the process of urbanization, because the cities are co-located along with the water body, you see, when the urbanization was lesser, density of urbanization was lesser, then the width of the river was large. That means the carrying capacity was large. But as the urbanization increased, the capacity of drainage system, river has shrunk, because people have encroached within the floodplain of the river, right? No, so once that happens, the capacity is getting lost. Surely the slums and squatter which are located or in close vicinity to the river, they will surely going to be get affected. That's how in the planned urban system, what is being educated is sustainable urban drainage system philosophy. It states, while we are preparing our master plan, we should also think about the sewerage master plan, water master plan, or the storm water management plan. Because what is being required, see, most part of our city, no, we have got the urban drainage system and also the stormwater drainage system. They are together. I mean, the stormwater drainage system and also the sewerage system, both are co-located. Water gets mixed up. So the residual water, because of the storm water or the rainfall, that gets mixed up with the sewerage water, we are not able to recycle it. If these two water channels are separate in a sustainable urban drainage system, so what we are able to do, on one side we can take the sewerage water into the sewerage water management system, but it will be far more easier to recycle the storm water. Okay, so that's how these two systems have to be separate. Now, as I said, that intensity or the occurrence of such kind of urban floods not going to rise in the times to come, because there is a threat of climate change. Reason being, there are studies which states that because of the certain climate change, because of the rise in the temperature, I mean because of the anthropogenic activities, there will be rise in the temperature to the extent of 2 degrees or more. Once this happen, then what will happen? It will have got its own after effects. There will be number of rainy days will decrease, and flash rainfall or the flash floods will increase. Okay, and subsequently, because of such kind of climate change phenomenon, what will happen, that snow melt will be happen early, and also the water, no, the snow, because of the increased snow melt and early snow melt, this water will be going finally to the sea and ocean, which will cause the rise in the sea level. So those cities which are coastal in nature, they will get inundated. We'll be losing the land surface, in fact. So that's how we have to be cautious, where there is a need to conduct the studies while linking the climate change with the phenomenon of urban floods. That's how Ministry of our Housing and Urban Affairs of our country, Government of India, no, they has brought out manual for the urban local bodies to define the standard operating procedure, that in the times of urban floods, what the urban local bodies should do, not only during the times of urban floods, but the forced the occurrence of urban floods, that it should not happen again in the times to come. What kind of remedial measure should be taken up? Though we know that once the urbanization happens and city gets densified, there will be hardly any opportunity to widen the stormwater drainage network. But it is always possible, but it will surely affect the life, day-to-day life. So that's how we have to deal this subject carefully, and more intense studies are required, and that at IRS we are surely doing it. But there are issues as well. First of all, we have to think about that how can we get the rainfall, because rainfall is one very important input for carrying out the urban flood related studies. So typically that we get the daily rainfall data, but the daily rainfall data will not be useful, but because we require continuous rainfall measurements. So rainfall stations are required to get the high intensity rain, time domain dependent sub hourly rainfall data is required. So fortunately we have got such kind of data available from the satellite based measurements. Okay, second important issue is because the undulation within the city that will not so high as compared to the mountainous region, right? No, so that's how the higher resolution DMs are also required to understand better understanding of the water movement within the city. Then once we are developing with this such kind of no models, so that ideally what should happen, that based on the certain magnitude of rainfall, can we do some kind of forecasting or the nowcasting, that this much volume of rainfall has occurred, this part of the city will get inundated, kindly evacuate. Okay, or with these part of the city we have to increase the urban drainage system. So such kind of real time flood forecasting is required. So this is happening in our country, like in the recently city like Chennai, already exercise is happening, or elsewhere also our researchers community, they are coming out with the proposals for the real time flood forecasting. I hope you have found this hour-long session useful. Okay, now over to you. I shall be happy to give the answer to your queries. Thank you very much for your patient hearing. Thank you.